Welcome dear students. In this video we are going to learn how Eratosthenes measured Earth's radius. A small mention is made of this event in middle class geography books. I got interested in making this video when my nephew, while studying his geography book, asked me how Eratosthenes must have measured the Earth's radius. So here we are with this video. The Earth's radius is the distance from its center to a point on its surface. Its value ranges from 6,378 km at the equator to 6,357 km at a pole. Thus, the equatorial radius is more than the polar radius. This is because the Earth is not a perfect sphere, but it is an oblate spheroid, and it is slightly flattened at the poles, which makes the polar radius slightly smaller than the equatorial radius. And the mean value is taken as about 6,371 kilometers. Eratosthenes was a Greek scholar, mathematician, and astronomer of the 3rd century BC. He is famous for being the first person to calculate the circumference of the Earth. Let us see how he must have calculated the Earth's surface, Earth's circumference, and hence the radius. He chose two places, Syene at Aswan and Alexandria in Egypt, which are 787 km apart. Let us recall some basic concepts which will help us in understanding the procedure and calculation. First is that light travels in a straight line. Second is the sun being extremely far away from the earth. The sun's rays fall parallel to each other at the earth. Third is circumference of a circle of radius r is given by 2 pi r. And length of an arc of a circle of radius r subtending angle theta at the center is given by theta upon 360 into 2 pi r. That is, if a circle is given as shown in the figure, and AB is an arc of that circle, and R is the radius of that circle, and the arc AB is subtending an angle theta, then the length of the arc AB is given by theta upon 360 into 2 pi r. At summer solstice, which occurs from June 20 to June 22 every year, the sun's rays fall vertically at Tropic of Cancer. At this time, the sun is at its maximum northern declination, which is about 23.5 degrees. At local noon, when sun passes the local meridian, it is exactly overhead, and a pole erected at 23.5 degree north latitude will not cast any shadow. Okay, now we come to the main subject. The circle represents the earth. Three vertical lines in red color, they represent the sun's rays falling from the sun on the surface of the earth. S is Syene, which is presumably at 23.5 degree north latitude, so that the sun's ray is falling exactly vertically, and if we extend it, it passes through the center of the earth O. And A is Alexandria, and the distance SA, that is the distance between Syene and Alexandria, is 787 km, which is represented by an arc of the circumference of the circle. AB is a vertical stick which has been erected at Alexandria, and AC is the shadow cast by the stick AB, because the rays are not falling overhead at Alexandria. They are falling at an angle to the stick. So that is why the stick AB is casting a shadow. Now the angle made by the ray of the sun with the stick is theta, that is angle ABC, which is theta. Eratosthenes measured this angle to be 7.2 degrees. Measuring of this angle is very easy. One can tie a string to the top of the stick at B and stretch it to the tip of the shadow at C and measure the angle ABC with the help of a protractor. Otherwise, simple trigonometry can be used in which tan theta is given by perpendicular upon base. So tan theta is equal to AC upon AB. So length of the shadow upon length of the stick will give tan theta, with which we can calculate theta. So Eratosthenes measured that angle to be 7.2 degree. Now because the rays are parallel, so this ray which is making an angle with AB is parallel to the ray which is passing through S. Now because they are parallel, so if we extend the line joining the stick, that is AB, it will pass through the center of the earth because it is vertical to the surface of the earth, and which will give us angle SOA is equal to theta, because both the rays are parallel to each other and these two angles SOA and ABC, they are alternate angles. So angle SOA is also equal to 7.2 degrees. Now we use that geometrical formula of measurement of arc. Now SA is equal to 787 kilometers. That is the distance between Syene and Alexandria, which is equal to the length of the arc. Angle SOA is equal to theta is equal to 7.2 degrees. Therefore, as per the formula, SA is equal to theta upon 360 into 2 pi r. SA is equal to 787 is equal to theta is 7.2 divided by 360 into 2 into pi is 3.14 into r. 7.2 upon 360 is 0.02. So 787 is equal to 0.02 into 6.28, which is obtained by multiplying 3.14 and 2. So or r is equal to 787 upon 0.1256. Thus the radius of the earth, that is SO or AO, is given by 6265.9 kilometers. And going by the fact that this calculation was carried out in 3rd century BC, that means quite more than 2000 years back. So this calculation or this result is remarkably accurate. So that's all with this video. For more videos related to education, math concepts, puzzles and Gurbani, do subscribe to this channel. Thank you very much. God bless you all. ਤੁਹਾਡਾ ਸਾਰਿਆਂ ਦਾ ਬਹੁਤ ਬਹੁਤ ਧੰਨਵਾਦ। ਰੱਬ ਰਾਖਾ।